Hello, my little mathematicians. Today we're going to explore exponents. Exponents you can kind of think of as repeated multiplication. Okay, so to kind of get us started on this, we're going to explore with this word problem right here. So you can follow along on page 239 in your textbooks. Bacteria reproduce by dividing. And you're like, wait a minute, you just said that it's repeated multiplication. So what do you mean by it's dividing? So if you have one single cell, that cell divides or splits into two cells. It replicates. And then each of those split in half. So now this one splits into two, and this one splits into two. So you went from 1 to 2 to 4, and so on. And so to represent these scenarios where you have things that like keep dividing in half, we're going to use repeated multiplication or exponents to represent it. So we don't have to write it out so many times. Okay, so for instance, when you first start, if you have, after no time has passed, you start with just one little bacteria. Okay, then after 1 hour, it splits in half, and so that 1 became 2. Now that you have that 1, it split in half to 2, right? Now this one splits into 2, and this one splits into 2. So now how many do you have? 1, 2, 3, 4. So 2 times 2 is 4. What do you predict is going to be the next one? Is it 2 times 3 and 6? Is that what you think? Well, what's 2 times 2? 4. What's 4 times 2? 8. Not 6, but 8. And then look what happens. Like the reason for that is this one right here splits into 2. This one splits into 2. This one splits into 2. And this one splits into 2. How many do you have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's not like 2 to the third power isn't 2 times 3, but it's 2 times 2 times 2. It's 2 times itself 3 times to give you an answer of 8. See if you can figure out what you think 2 times itself 4 times is. Okay, well, 2 times 2 is 4, and that 2 times 2 is 4, and 4 times 4 is 16. So 2 to the 4th power, or 2 times itself 4 times, is 16. Okay, so first of all, they wanted us to complete the table. We did. What patterns do you see in the total bacteria column? What do you see? If you said that the total bacteria doubles each time, or each number is double the previous number, that's right. Because look, 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you're taking the previous answer and then you're adding one more 2. So you're taking the previous answer and multiplying it by 2. So we'll say the total bacteria doubles each time, time has passed. Or you could say each number is double the previous number. And if your wording was a little bit different, but it says the same thing, that's totally fine. Okay. For B, they want us to say at 2 hours, the total is equal to the product of 2 2's, 2 times 2. At 3 hours, the total is equal to the product of, what do you think? Hopefully you said 3 2's. At 4 hours, the total is equal to the product of, what do you think? Hopefully you said 4 2's. Okay, so to reflect, communicate mathematical ideas, how is the time in hours related to the number of times 2 is used as a factor? What do you think? That's the first question. How is the time in hours related to the number of times 2 is used as a factor? Well, I'd say the number of hours dictates how many 2's to use. Right? Isn't it? So at 3 hours, you used 3 2's. At 4 hours, you used 4 2's. So that was the first part of this question. Now, the second part of the question, they asked us, show how to find the number of bacteria at 10 hours. Oof, what do you think? Well, how many 2s do you think there's going to be? If you said 10, that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And just double check that you have 10 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so the easiest way is to group it up. So some people go 2 times 2 is 4, and then 4 times 2 is 8, and then 8 times 2 is 16. You could do it that way. That way works. I just like to group them. And then I'm like, all right, that's 16, that's 16, and I'm going to bring down that 4. And then I know 16 times 4 is 64. And now I just have to do like one complicated multiplication of 64 times 16. And so if you go ahead and you multiply that out, you should get 1,024. Now, if this were a quiz or test, obviously we wouldn't give you that big of a number to multiply out. Okay, but that's how it works. Let's go ahead and turn the page and try some more of these. And as you can see, like if they said you don't have to solve it, but just write it out, what's a better way to write this? Instead of 2 10 times, what if we did like 2 to the 10th power? Let's go over those vocab words. Okay. So right here, if I take a look at the top of the next page, it says a number that is formed by repeated multiplication of the same factor is called a power. That little tiny number right there. You can use an exponent and a base to write a power. For example, 7 to the 3rd power, or 7 cubed, means the product of 3 3s. Okay, so right here, the base, if we take a look at the first part, the base is the 7 right here. It's the number that's being multiplied. Okay, so 7 is being multiplied. And then the exponent tells you how many times you're multiplying that number by itself. So right here, that little tiny 3, that's the exponent. And sometimes you're going to hear it referred to as a power. Power means the same thing as exponent. Okay, and it tells you how many times the base is multiplied by itself. So 6 to the 2nd power means 6 raised to the 2nd power, or 6 times 6. What is that? It's 36, right? 6 times 6 is 36. It's not 6 times 2, it's 6 times 6, which is 36. This would be 7 cubed, or 7 to the power of 3, or 7 raised to the 3rd power. Those are all ways to say 7 to the 3rd power. Okay, and that would be 7 times 7 times 7. So let's go ahead and see what some of this would look like for our homework. It would say, use an exponent to write the expression. You pray that these are the types of numbers on your quiz, because look how easy this is. All you do is you write the base is 3, and how many times is the base multiplied by itself? 1, 2, 3, 4, 5 times. There you go. That's the exponent. Done. No work. So you're like, oh yeah, I totally hope they fill the quiz up with those. This one, okay, you have a base of 4 to the 5th. And how many 4 to the 5ths do you see? 1, 2, 3, 4. I would mark you wrong. And you're like, what? But 1, 2, 3, 4, and there's 4 of those 4 to the 5ths. I would need you to put parentheses around the 4 to the 5ths. And you're like, what? Really? Like, what is the difference between parentheses and not parentheses? Okay, well, let me show you. If you had 3 to the 4th and you just were lazy and you just put a 2 here, that might be mistaken that, oh, just the 3 is being squared. So 3 times 3 is 9, and that just stays a 4. That's different than this whole thing being squared. That's saying 3/4 times 3/4. So you get 3 times 3 on top and 4 times 4 on the bottom. So that simple little thing of having parentheses changes the answer from 9 to the 4 or 9/4 to 9/16. That makes a huge difference, right? So yes, parentheses matter. If there's no parentheses, it's just squaring that number. If there is parentheses, that whole entire thing is being multiplied by itself that many times. So yes, please put parentheses when needed. It does matter. All right. Why don't you go ahead and try 2 through 5? Pause the video and then unpause when you think you have them. All right. You unpause, you're back with us. You had a base of 4 to the 1 to third power. You had 6 to the power of 1 because there was 1 6. Here you had 1/8 squared, and if you put it like this, you missed it. You needed to have those parentheses because it's 1/8 times 1/8. It's not just the one that's being squared, it's the whole thing. Okay, and then this one, 5 to the 1, 2, 3, 4, 5, 6 power. So that would be 5 to the 6. All right, hopefully we got most of those right. There's one other lesson that we're going to explore today. Go ahead and turn to the next page, page 241. And that other example that we're going to talk about is the fact that any non-zero number raised to the power of 0, so any number raised to the power of 0. Okay, I just took off the non-zero number because meh. Okay, so any number raised to the power of 0 is 1. So 5 to the 0 power is 1. It's not 5, it's not 0, it's 1. And you're like, why in the world does that work? Okay, well, right now, I want you to go ahead and turn your paper sideways and pause this video and go ahead and copy this down. Okay, right here, what you see. Copy this down. Okay, now once you have it copied down, you unpaused it, you're back with us. Do you see the pattern of why anything to the power of 0 is 1? Okay, so you know 2 to the 1 is 2. 2 squared, that's 2 times 2 is 4. 2 times 2 is 4 times another 2 is 8. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay, 3 to the first power is 3. 3 times 3 is 9. And then you know that you're just multiplying by it each time you go this way, right? Okay, so we see the pattern. 5 is 5. 5 times 5 is 25. 5 times 5 times 5 is 125. As you move up, what are you doing each time? Here, you're multiplying by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And so on. Okay, so this time you're going to be multiplying by 5 each time. This time you'd multiply by 10 each time. So if each time I move up a level, I'm multiplying, what happens when you want to go back a level? You would divide by it, right? So 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. What's 2 divided by 2? Is it 0? No. 2 divided by 2 is 1. And 9 divided by 3 is 3. 3 divided by 3 is 1. 25 divided by 5 is 5. 5 divided by 5 is 1. And so if you follow the patterns of the exponents, you know, this was to the third power, this was to the second, to the first, to the 0. So when you back up a step, you're dividing by that base. And when you divide a base by itself, you get 1. That's why anything to the 0 power is 1. Okay, in case you were curious. Hopefully now you can just accept that rule, but if you were confused as to why it works, that's why it works. Okay, so now let's go ahead and take a look at some examples. So for the first one, it says find the value of each power. This is 10 to the 4th. So that's 1, 2, 3, 4 tens, right? So that's 1 times 1 times 1 times 1, which is 1, with 1, 2, 3, 4 zeros at the end. I love bases of 10s. So nice. Okay, and then 0.4 to the third power is saying 0.4 times itself 3 times. So that would be 0.4 times 0.4 times 0.4. Well, 4 times 4 is 16. There's 2 numbers after the decimal, so 2 numbers after the decimal times this 0.4. Well, 16 times 4 is 64, right? And there's 1, 2, 3 numbers after the decimal, so 1, 2, 3 numbers after the decimal puts us there. So it's 0.064. You could put 0.064 or 0.064. Either one's fine. Okay, what do you think the next one is? 3/5 to the 0 power. What is it? Remember, anything to the 0 power is 1. Okay, and then lastly, right here for our last example, it says 2/3 to the 2nd power. So that's 2/3 times itself. So 2 times 2 is 4 on top, and 3 times 3 is 9 on the bottom. So 2/3 squared is 4/9. Why don't you go ahead and try 6 through 9 on your own right now? If it said to find the value of the power, that means you're multiplying it out and finding the actual value of it. So go ahead and try to solve those. Okay, now you unpause the video and you're back with us. This is 3 times itself 4 times. So there's 1, 2, 3, 4 threes. Well, 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. Okay, 1 to the 9th power. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, 1 times 1 is 1. 1 times 1 is 1. No matter what, you're still going to get 1. So why even waste our time? Okay, for this one, you have 2/5 times 2/5 times 2/5. You have 2/5 times itself 1, 2, 3 times. Well, 2 times 2 is 4. 4 times 2 is 8. 5 times 5 is 25, and 25 times 5 is 125. So that's 8 and 125. And then finally, that's not 24. Please don't put that. Okay, it's 12 times itself twice, right? 2 12s. And what is 12 times 12? It's 144. So the difference between the directions, okay? If it says find the value of each power, then they would give you this and they want you to multiply it out and find the value. What does that actually equal? Versus if the directions say use an exponent to write it, they wrote it out for you and they just want you to say, okay, there's 5 3s, so it's 3 to the 5th power. Okay, so read the directions. These are hopefully the directions you want, right? So much easier than these, but still not complicated. All right, good job, my little mathematicians. You have now mastered repeated multiplication, or the fancy word for that is exponents.